Okay. Okay, so tonight we're going to look at lesson 2.6 and possibly 2.7. We'll see how this goes. It says, sit back and watch your money grow. The quote, I don't really know much about this quote. It says, if I take 30 steps linearly, I get to 30. If I take 30 steps exponentially, I get to 1 billion. And that's what we saw in lesson 2.1 when we had that initial idea of simple interest and compound interest. So at the bottom here of page 207, it's asking us to write down what we know so far about linear and exponential growth. So what do we know so far about linear and exponential growth?
Linear is addition, correct?
Yeah.
Now, is that a subtraction as well?
Yeah.
Okay.
So if it's going, if it's going uphill, it's going to be addition, right? And if it's going downhill, it'll be subtraction, which is a negative slope, right? That addition and subtraction is your slope rate of change.
Okay.
And we know that when we have that repeat addition, then we can usually formulate this into an equation of y equals mx plus b. And then one of the worksheets asks you for parameters. So when you do the modeling on Desmos, the word parameter comes up in that box, but the parameters are m and b, where m is your slope, which is your change in y over change in x, and then b is your y-intercept. I'm doing some summary of what we've learned so far. Your y-intercept or your starting value. And what do we remember the little bit that we did about exponential growth? What do we remember about that?
That's repeat repeat multiplication.
Yep, so that's repeat multiplication. And we did kind of put an equation together when we learned about the compound interest. We said the output can be modeled by, you've got the starting value, so the parameters are A, which is your y-intercept starting value, times B, and then we had that exponent, that repeat multiplication when we were talking about the compound interest. And the B is your growth factor, that multiplier. And we're going to formalize this today. So it's just kind of a summary of the two. And then 2.6, we're going to formalize it. We're going to work with exponential 2.7, and then 2.8 is kind of looking at a blank data set and deciding if it's linear or exponential. So it's kind of putting it all together. Is everybody okay to move on?
Yep.
Okay. So I'm going to get you going on this. So on page 208, it says, if most people won $15,000 on a game show, they'd go on a spending spree. Sounds fun, but not you. It says you're going to save your money. So we're going to pretend that you are super patient and you are going to wait 40 years in an investment account, fixed rate, which means you're going to get pretty much going to get the same interest every year. So they gave us data in a table from year 0 when we won the 15,000 all the way through year 7, and the value in the account. And then the graph, they went way beyond the 7 years. So they went all the way through the 40 on the graph. And so using some of the strategies that we've already learned in Desmos, you should be able to answer questions 2 and 3, figuring out what type of growth it is and what you're multiplying by. And I'll be right back. I'll let you look at that. Whoops. There we go. Now I'm using my paper. Yay. Darla, are you there? We haven't gotten to see your smiling face or your voice yet.
I'm here. The police are arresting people. Sorry.
Huh? At
The
your
police
house?
are arresting my neighbors.
Uh-oh.
Oh
No
my-
wonder you're going on. You're probably wanting to watch that.
I am.
Well,
And listening.
and what?
And listening.
Well,
Uh-oh.
turn on your screen so we can see what's going on.
Hold on.
Okay, I'll be right back. You guys figure this out. I'll be right back.
I did this today on my lunch. I did this where she had it taped, so I went and worked through it with her today on my lunch. Uh-oh, what's going on with your neighbors anyway?
I think they're crackheads.
Oh, boy.
They don't really live there, but the police car is over there
Okay.
on the other side of my bushes.
Hmm.
And he's already arrested 2 people.
Oh, wow.
And I don't know where the lady went with the little kid.
Is he by himself, the police officer?
Yep. Oh, there's the lady. You see the kid?
You barely, yep.
Yep.
Oh, yeah, I can now. She's holding him or something?
Mm-mm. She's next to him. I think she's strung out on drugs or something. She's
Oh,
like
oh.
weebling and wobbling and doing whatever.
Oh, well, that's real good to be around your kid.
Mm-hmm.
Now,
I ain't
I,
even acting right.
So what's going on over there?
I don't know. Oh my gosh. Scary.
Mhm. Okay, so how can we tell? It says for each value in the table after the initial investment, divide the amount by the value of the account by the previous year. What do you notice? So if we were to take 16,050 and divide by 15,000, and then if we check another one,
Oh, it's a steady slope up.
mhm, what do we notice that to be?
Oh, it just
Well,
goes
I'm-
on my
you
stressful
know, I'm
day.
trying to get even though I did this today on my lunch while you did it. I did it with you on my lunch today when you taped it.
Cool.
So I like to do that. So then if I have any questions while we're doing this, I can ask you questions too.
Right.
So yeah, I did the whole Desmos and saved it and everything.
Awesome. So what did you get if you divided these? What did we end up getting?
1.07.
1.07. So if you do them all, my folks at home will find out that it's 1.07 is the multiplier.
Mhm.
So number 3 says, what does your result tell you what type of growth?
Exponential.
Yep, it's exponential. And let's just put because we take one value and multiply by 0.07 to get the next. And it says, find the relative change in value for each year in the table compared to the previous year. What can you conclude? So when we talk about relative change, we're talking about new minus old over old.
I made sure I keep a little note of that for when we have our midterms. So I
Mhm. Yeah,
remember
we've been doing that since unit 1,
Yeah.
1, I think, actually. And so we can do any number of these. They should come out to be about the same. But let's say we did the 17,173.50 and subtracted the previous 16,050 divided by the 16,050. And what did you get for the relative change?
Mine was, I did the 1650 minus the 15,000, 0.07.
Mhm. And are you seeing my Desmos now? So I'm just going to show everybody at home. So when we
I was trying to bring mine up because I have all of it done on mine, but
yeah, we could see yours.
yeah, if I can get to it, I'm trying to minimize this so I can bring my Excel up or my Desmos up. Hang on just a moment and see if I can get. Come on.
So if we do that one, we get 0.07. And if you do them all, there's not room here. It'd be nice if they did that in the table that we could show, but it looks like all of the relative change for all of them is 0.07.
Correct.
So 0.07 means we have a 7% increase. Because that's our relative change or percent change. Okay. I said,
How can I minimize my screen with you so I can bring my Desmos? I'm trying to hit the,
at the top right of our decimal screen, you should be able to, there should be the button that says view, or maybe it's in the middle,
oh, over here on the right, on the top. Okay.
and under view, if you
Yeah.
click on view and then just do exit full screen.
Okay.
Mhm.
Oh, let me see. Exit full screen. Okay. Then let me minimize this and get mine up. Okay.
You want to share your screen?
Oh boy, where'd it go? Let me untitled graph. Oh, let me see which one I did. 2.6. If I can open it all the way. I have lesson 2.6 intro to exponential growth on here, but I'm clicking on it and it's not letting me open it up all the way. Oh, here, open graph. Okay. Okay, and then click back on this to make it, oops. Okay, let me see if I can get this up so I can share my screen. Okay. Share.
Mhm. No spot on.
Okay, there's mine. Can you see mine? No?
Yeah, yes, we can. Awesome. So right there's your change on the left, your relative change at 0.07. Awesome. You're going to scroll down and there's your graph. Awesome.
Yep.
And then number 5 says find the value of the account after 10 years. Did you do that one? Number 5? Yeah.
I did.
No,
What, oh, 10, 5. $29,507.27.
Yeah. Did you do it in there? Let me, I just,
Right there.
yeah. So you took 15,000 was your starting value,
Yes.
and that's your A. And so we have, I'm just going to write this on number 5. So 15,000 times 1.07 to the 10th. And we came up with after 10 years, we would have 29,507 and 27 cents.
Mhm.
Woo woo. Okay.
That's why I like watching it when you tape them, so I can stop and go back if I have to, if I don't understand what happened. So that's nice.
Yay. And then number 6 says your answer to question 3, use your answer to write a formal equation, which you did for us there below. And then And then it says verify that, number 7 says verify that your equation gives you the same, generates the same values in the table.
Yep, so I looked on here and then went back to page 208.
Mhm.
What was it? 20? Yeah, 208.
Mhm. Awesome. And you put that equation in that you came
Yes.
up with?
Yep, see, it's up into the top and then
Mhm.
one all the way down.
Awesome. So if you exit out of, can you exit out of that and then show us how you type it as a y equals again for the folks at home, just in case that they're like, how do I type that in again?
Like down here.
Sure.
Let me see here. Let me see. So you want me to do the same one that's right here?
Yeah, or you can just delete that one and just type it over and
Oh, okay.
it'll come back up.
Okay.
You can just hit the X button
Okay,
in your box there. Yep.
all right, there we go.
Yep.
Where am I at? So it doesn't matter where I go, right?
Nope, or you could do it in the blank one up there.
Okay, so then, well, it's right there and then,
Yep, so y equals,
right. Yeah, y equals 15,000, 1.07.
mhm.
Huh.
Oh, we want to put X, right?
Oops,
so
X. Oh, I copied
it-
one on the other. side.
Yep, the X. And then, so there's the graph. And then how do you get the table again for the folks at home? What do we have to do?
Let me think what I did. You have to put 0 and then 15,000. Uh-oh, where did I put it in there?
Nope. So I would type it
Oh,
again.
do I have to do graph?
If you go up to the gear, but you have to do that while you're in the,
Oh, in this box. In this,
yep. And now you can go to the gear. Yeah.
and then this.
Mm-hmm.
Okay,
And then you can, yep, and then you can validate all your years.
yep, and then 1, 2, 3, 4, 5, 6, 7,
Excellent.
9, 10. How many did we go? 11 or 12?
I think they just had 7 in their box,
Okay.
but so that did validate.
Oh, that one for the 10, for how many after 10 years?
Yeah, so you could do it that way. That's
Yeah.
one way you could do it.
Right.
So if you stop, if you don't mind, well, and also you typed it in up above. You typed it in with the 10 in there.
Oh, up here? Right
Yeah,
here.
right there. Yep. So you also put it in the equation form and let
Oh,
Doug
right.
let's calculate it that way. Yep.
Yeah, how did I end up with this here? That's not supposed to be there. That's supposed to be that. Okay. Whoops. Why doesn't that go away?
What?
I'm trying to use that little, what do you call that little thing that shifts to make the
Oh, the
exponential?
carrot, it doesn't go away because you have it on a note. You made a note there.
Oh, gotcha. Okay.
You
That's
type.
why I wondered why it wasn't going away.
Mhm. Yeah.
Okay.
And then at the bottom of page 209, we introduced the function notation. So if you don't mind unsharing your screen out
Okay.
on my paper. Ouch, ouch.
Get one over here.
And so if I
Oh,
go, yep, so if we're gonna go to the bottom of page 209. Oh, it looks like you're still sharing.
No, I'm trying to undo
Oh,
it.
that's great.
Stop
Oh,
share.
yeah.
There we go. Stop share. There we go. Okay.
Okay, there. So here at the bottom of page 209, here at the bottom, they talk about function notation and what a function is. So a function is basically just a formal way to write a recipe, like an equation. It says a function is a relationship between two quantities where each input produces a unique output. And so we are going to write ours in this function notation here of f of x. So in the circle box, when we write this, it says the output of a function named as described by the symbol. We say it f of x. It's not f times x with the parentheses. It's saying f of x, which means that x is my input into the function. So if f is the name of my recipe, right? X is one of my ingredients or my list of ingredients. And then what comes out is my product for my recipe. So if we turn to number 8 on page 210, oh, actually, we can not worry about number 8 because it's using other stuff in Excel, which we're not using. We're using decimals, which is better. Okay, so number 9, it says for the function describing the value of $15,000 investment, find f of 12 and describe what it means. So f of 12 means we're looking for the output y when x is 12. So Teresa did show us with hers. But if I show you my decimal screen here, we can type y equals, and it's 15,000 times 1 times. And we can go to, on our graph, when you type in just the equation and you don't make the table, it will let you do a slider, but for some reason it won't do that if you've done the table. So I'm going to scroll down because I'm going to go to 12. Now we could just take our slider and try to get to 12 right there at 33,782.874. But what's cool, I learned, a student said that they figured this out. If you go over here to the line underneath my equation, I just type x equals 12, it'll draw a vertical line, x equal to 12. And then if you stay right where you typed it, it puts a little X, a little gray dot where the intersection is, and then you can hover over the dot, and that is the intersection. So, whoops, let me go back to my intersection here. So the intersection says that after 12 years, there is expected to be 33,782.87 in the account. Which is awesome. I didn't know we could do the X equal thing.
Oh, that's cool though.
Very cool. So number 10 says, let's look back at the graph that illustrates the value of the account. Trace along the graph. So we just did that. So if I go onto my graph and I trace along, we can just make some comments about how quickly the money is growing. So it's growing more gradual here, but then it grows quicker and quicker and quicker, right? And almost looks like it becomes straight up the more you zoom out.
Yeah.
I just made that note on mine at number 10. It is growing quicker and quicker. Okay, so I was just going to show my paper just so everybody can kind of see the things I've been writing. So for the number 8, 9 with the F of 12, I just wrote this sentence: after 12 years, there's expected to be 33,782.87 in the account. And there's my comment for number 10. It's growing quicker and quicker. And then number 11 says, how much interest will you earn from 0 to 5 years into the investment? So this will be the difference in the value after 5 years and the initial investment. So essentially it's f of 5 minus f of 0, right? The function at 5 and the function at 0. And And then 12 is asking us something similar. So we can go to into Desmos, and I'm going to show you that you could just go over here and just do the line. Actually, we can just go up here now. If I have it make a table, right? If I have it make the table, I can just go into my table and say 5. And then, so at 5, there should be $21,038.28 minus the 15,000 that we started with. So do that calculation here, 38 and 28 minus the 15,000 we started with right there. And we can see that we have gained $6,038.28 in interest, which is awesome.
You could also look back on the actual graph or the actual table on 208. So you could see what it was after 5 years already, right?
Yep, you could do it that way too. Yep, I forgot that 5 was in there. And I think 11 is our lesson check. So 11 is our lesson check. So let me just go and make sure everybody sees my paper here for the lesson check. On 11. So this is the lesson check. And I think if you just type 6038.28, you can put the $sign. I think I put both would be allowed. So. And then number 12 is saying, how much interest will you earn between years 35 and 40? So I'll let everybody get working on that. So that's the function at 40 minus the function at 35. So what did you ladies come up with?
Well, the answer, you want the answer or you want what we did?
Sure, you can kind of tell me what we did, and I can do things up here in the table too, right? So in the table, I can find 40 and 35.
Yep, and then you subtract one from the other.
Okay, and when
Right.
you did that, what did you get for the difference?
$64,460.15.
460 or 468?
460, I thought, unless I didn't do it right. 7, 1.
See, 2,
Oh, it should be, you're right, 8. I just didn't write it down right.
that's what, because you know what?
15 minus 8 is 6.
Well,
Right.
you
Sorry.
see my handwriting, and so I went and looked at my answer key thing that I made, and I can't read what it says. So I'm like, well, I hope she figures. So I typed it up. So we got it figured out. 68. Good. So wow, that's a huge difference, right? Compared to the first 5 years.
Jeez,
I know.
you can leave the money there.
Yeah. So the longer you leave it there, you're getting interest on a bigger base amount, and you're getting a multiplied interest. So it's crazy. And then number 13 says, describe what you can learn from comparing the answers 11 and 12. Also describe how that fits in with your answer to question 10. it verifies that you're definitely growing by more amount as time passes, right?
Mhm. The longer you wait, the more money
Yeah,
grows, right?
yeah. The more time you wait, the more your money grows. We like that. I like that a lot. Okay. The next little set of questions are all about a different type of exponential situation. And this one is called exponential decay. So there's just like linear, we could have an increasing slope or a decreasing slope. So this is exponential growth is increasing, exponential decay is decreasing. So it says coffee is a popular morning drink because the caffeine contains acts as a temporary stimulant. Once the caffeine gets in your system, the amount dissipates exponentially, assuming that you don't add more, of course. So I like to add more. Answer every question except for 2 and 6 with a full sentence. So I'm gonna let you, so Tracy's already worked on this. Darla, you're working away on it. Are you caught up with us here? Okay, she's giving us a thumbs up. So Tracy already have hers. I'm gonna let Darla look at hers because it says if you're the coffee drinker represented by the table and graph, how much caffeine was initially in your system?
One hundred and 80 caffeine.
180 milligrams. So we could see that either from the table, we could also see it from the graph, right? So 180 milligrams. And then it says, find the relative change in caffeine for each 1 hour period listed in the following table, round to the nearest full percent. So we did relative change in the last part of the lesson. And relative change is new minus old over old. And so I'm going to write out what the first one would look like, and I'm going to let you, I'm going to do 144 minus 180 over 180. That's an example of one of them. So this would be a negative 36 over 180. And when we do that, negative 36 divided by 180 for that one, I get a negative 0.2. So I'm gonna let you ladies, I'm gonna let Darla finish up those and see what we get. That's recording for a minute. Okay. So did we get the same amount on the relative change each time?
Yeah, pretty much a zero, negative, or 20%, correct?
Yep, that's what I had too when I did them all. So a 20% decrease between hours. Yes. Okay. So at the top of page 213, it says, complete this important statement about exponential change. A quantity either grows or decays exponentially when the blank blank in that quantity is blank. So we could say the relative change And I figured out what word I think this should be. And that quantity is constant. So if the relative change is negative, it's going to be a decay. It's going down. If it's positive, and it's going to be a growth. But as long as that relative change is constant, then we know it's exponential.
Either whether it's up or down, right?
Mhm. So looking at the graph of the caffeine remaining in your system, describe what exponential decay looks like compared to exponential growth. So we said this is growth. And we said this is decay. So, and a student this morning made a comment that in growth, it starts off slow and grows quicker and quicker and quicker, right? In decay, they made a comment that decays quicker at first and then slows down. I'm like, oh, I never even thought of that.
Well, then it's just the opposite of the growth, because the growth starts out slow too. Right? Just the
Yep. So left to right, the growth starts slow and gets quicker, but left to right, the decay actually goes quick and then gets really slow.
Yeah.
So it's just an opposite.
Effect.
Yep. So number 5 says, what's the multiplication factor that you'd need to multiply by previous hour's amount to get the next hour's amount? So to do that, we learned that we could take a value, right, and divide by the previous value to find that. So if we do 144, oops, not 1 point, so 144 divided by 180, and then let's try another one, 73.7 divided by 92. What do we get? And what about 37.7 divided by 47.2? When we get these, what do we get? So I'm going to try some here. So 144 divided by 180, we get 0.8. And then 73.7 divided by 2.2. So round it up to 0.8. 37.7 divided by 47.2. And round it up to 0.8. So it looks like they're all 0.8. So I'm going to show you how you know how this should be true. Okay, so our growth factor, or actually, yeah, our growth factor, which is what we're trying to find, right? Our multiplier, that is B. And B is equal to 1 plus our relative change. So we could see that in the last parts of the lesson that we did. We could see that our multiplier was 1.07, and we said our relative change in question number 4 was 0.07. So if you add 1 to it, you get your multiplier. And that would make sense, because if we said 1 plus our relative change here, we said was a negative 0.20. And if we take 1 plus a negative 0.20, we get 0.8. So if we don't know what the multiplier or the growth factor is, we're going to take our relative change and add it to 1. So if they tell us it's a 20% decrease, we know that the relative change is a negative 0.2. If we know that it's a 7% growth, then we know our relative change is 0.07, and we can find that multiplier by adding 1. And likewise, we can find our relative change by taking B, the growth factor, and subtracting 1. So if we did 0.8 and subtracted 1, we would get a negative 0.20, which is the negative 20%.
Okay.
And we're going to get practice on that on the worksheets. So number 6 says, use your answers to question 5 to write a function of the form f of x that describes our amount of caffeine left in your system after x hours. So f of x always equals y, just remind myself of that. And then we started with 180 milligrams, right? And we said our multiplier is 0.8 because we're not getting bigger than 100%. We're getting smaller than 100%. We're only keeping 80% from hour to hour. So we could actually make a note down here. Keeping 80% of caffeine from hour to hour. So this is 180 times 0.8 to the x hours. And we can flip the page. And number 7 says, using a graphing calculator to verify that your equation gives you the values in a table in a given graph. So we can share our screen back to Desmos and we can go and prove that. Let's start a new graph here. So let's type in what we think is true. We think it's y equals 180 parentheses 0.8. There we go. And I'm going to leave that one there so we'll draw a graph that will let me have a slider, and then I'm going to do it again and I'm going to make a table out of one of them. Because once you make the table, you can't slide on it. I don't know why. I haven't figured that out. So this one up here in red is going to be, it's going to be on my, I can slide on it. And this one down here, I can type in the table. So I'm going to do my zoom fit with my magnifying glass, and there it is. And there I can slide now. I like being able to slide.
How were you able to slide with the one and not the other?
Once you make the table with the gear, it doesn't let you
Right.
slide. I don't know
Okay.
why.
So how did you get it on there in the right
I did
way?
it twice. I
you
just typed it
clicked on
twice. What?
Did you just click on the red one and then it could slide, and then if you clicked on the blue one, it showed that you couldn't?
Well, it's really the same thing, right? It's just the red over the blue.
Oh, okay.
It's
Got
just
you.
when I go to touch it with my mouse, it turns into red. That's all.
Gotcha.
Yeah.
Okay.
So it's blue in the background. See, my dots are blue,
Oh, okay.
but because I have it typed in, it's just an equation that will let me slide. So I don't know why it does that. It's weird.
Yeah.
So I'll let Darla work here for a minute on 8, 9, and 10. We'll take our time. We're no rush. Why don't we just take a little break and we'll finish this up. And then when we come back, we'll finish up 8, 9, and 10, make sure we're all good with that. 8, 9,
I'm
10.
just trying to do the Desmo thing.
Oh yeah, go ahead. Did you get your equation in?
No, I'm trying to figure out how to do that. I got it typed in, but
That's
I'm
okay.
trying to do the graph thing.
The what thing? The red?
The graph.
Oh, so if you've got the y and you've got y equals, just like I have it.
Yeah.
And then I copy it, I cut and paste it, and I put it down below again.
Right, I did that.
And then I did the gear.
Okay.
And then on one of them, I chose the table, so it would make the table for me with the same equation.
The
I had
table.
different
here,
numbers.
right?
Well, mine started at -2.
Well, mine says -2, but the other one is -220, 288, and you got 281.
Oh, do you have 180 and then in parentheses 0.8?
Well, I do.
And then, oh, and then is your X in the exponent or is it down below
Oh,
times?
it's in the lower one. That would be the problem.
That's what friends are for.
Well, I thought I did it right.
That's okay. We're just learning how to do it. It's all kind of a new thing.
Okay, there it is.
Remember,
Now,
remember.
how do you get it? How do you get it to mark the chart?
So, okay, so this is what you have so far, right? What I have right here.
Yeah.
So then all I did was I want to leave that one so I can actually grab on my graph. See how on my graph I can grab it and I can slide?
I don't have a graph bar though.
Well, because you haven't.
Maybe if I zoom out.
Right.
Well,
This is good. All these things are good because the folks that watching at home, they're learning too.
oh, nope. Nothing.
Did you put the graph off of the gear, right?
Well, not yet. So you can do it from here. So you have a
Alright.
color on your line right here. It shows the graph in a color. Just a minute. I can't see yours. Just 1 minute. Right. So now you're gonna have to hit your magnifying glass
Magnifying glass.
on the very bottom left of your table. There should be a little magnifying glass that says,
Oh. Oh, there it is.
and that adjusts the scale. So that's what I'm saying. Oh, wait.
But mine's not red.
Well, yeah,
Oh,
it's
well.
you can change it to whatever color you'd like.
I mean, mine's not even going the same way.
It's not going like this. No, it's not. Because you know what? You've got the times X still. Make it go up into the exponent. Put your X up to the top.
Do what?
In your table where it says 180 parentheses 0.8 parentheses,
Uh-huh.
I think you have times X and X needs to be up in the exponent.
It is.
Okay, let me stop sharing again. I can't see.
Oh, maybe. Hold on. There it is. I found it.
Yay, woo, we got it.
Okay.
Hallelujah.
I am paying attention.
No, I know you are. You know, that's the thing is if you don't ever make a mistake, you don't know what you know and what you don't know, and
Right.
so
I'm-
this is great.
I was
Folks at
trying to
home-
follow and I'm like doing step by step. I'm like, what is
No.
wrong?
But these are the same mistakes our friends at home are making, and they don't have me and a friend Teresa here to help. You know what I mean? So this is good. So see what I'm saying? Like right now, I can click, just watch, notice that I haven't made my table yet. I can click on my graph and I can slide. But as soon as I go and make
Mhm.
that gear, I can no longer slide on there. So I have to type it
Oh.
again. So I have to type it again, which is, I have to admit, it's quite irritating.
I see.
That's something that you can bring up to whoever makes these.
Yeah, I don't know who makes Desmos and
I see. Depending on which one you touch.
yeah. So
Because
so now I've got the blue one. Now I can slide again. It's making the same thing. It's making the same graph. It's just when it's just the equation, it'll let you slide. If you make it into the table, it won't let you slide on it. It's not the end of the world. But I'm just telling the folks at home, do it, make one that's just the equation to slide and make one that does the gear in the table so you can, type in different X's.
Because the one where you just slide will help you with number 10. Question number 10.
Right. Yeah, 9 and 10 can be done with that. So
Right.
if we go to if we go to number 8 says use the function you wrote to find the amount of caffeine left in your system after 150 minutes. Well, 115 minutes. And we do have to pay attention to the fact that everything we have is in hours, right?
Oh, so that's an what, an hour? That's 2 hours. 30 minutes.
So 2.5 hours. So we would take 150 minutes and multiply by 1 hour over 60 minutes to find out that that is 2.5 hours. So that's the X that we're looking at. So the function at 2.5, so we can go to Desmos and you can just go to your table if you want, which is super cool. I'm going to show everybody on Desmos on my screen here. That you can just go to your table and just say 2.5. So that's the benefit of having the table made with
Oh,
the gear. Now you can only do that with X. You can't type in a Y and have it give you an X, but you can type in an X, which is super awesome. So about 103.04 milligrams of caffeine left after 2.5 hours. Then 9 and 10 say, use the graph to estimate the amount of time needed for the amount of caffeine to drop to 40 milligrams. Describe how you found your answer. So 9 and 10 are essentially answering the same question. You can just kind of get them different ways. So I'll let everybody take a minute to play around with that. A couple different ways we can get there. So there's a couple ways we can do this. Anybody? Oh, what did I just do? Anybody find one of them?
On mine, I had just used the slide until you came to the till you kind of balance out to the 40 milligrams.
Okay.
Oh,
So
there you go.
yeah, so number 2, I said slide on the graph to when Y equals 40 and find X. That's an option. Another, and that's essentially number 10 with the table and the trace. The other way is if you go to, whoopsie, am I moving around here? If you go to Desmos and in a new line right here, you type Y equals 40. And then I'm going to scroll over so I can see the intersection here, or you can hit the, so I have to click on the Y equals 40 where I typed it, and then it will put a gray dot right here. So it looks like they intersect at 6.74 hours. So we see that it's very faint on the screen. So yep, as long as you have, if you notice my line where I typed Y equals 40, that's where my cursor is, it will automatically put the gray dot there for you. So 6.74 hours, we should be at 40 milligrams. And so 9 and 10 are kind of around the same thing. You could use a slider. And then the last question for 2-6 is number 11. Can we come up with situations that could be modeled by each of the following graphs? We try to come up with a situation we haven't looked at yet.
Well, that one looks like 11. The first one just looks like the chart for the $15,000 money you won from the game show. It just goes up.
Mhm. Yeah, can we think of any other situations you think that grow? That might grow really fast like that? Any other scenarios in life?
Not my retirement. That's why I'm still working.
What about some animal populations grow really quick, right? Rabbits, they say they're the animal population.
yeah.
So animal populations, bacteria usually grows exponentially as well.
Yeah, look at this COVID.
Mhm.
Mhm.
And what about situations where we have decay?
That could be radioactive. I saw that thing about.
Yeah. Radioactive material decays quickly.
Yeah, it says decays exponentially on the other page on the did you get it?
Oh, yeah. So, if you've ever had, I think it's an MRI, I'm not sure,
Yep. Okay.
it's an MRI, they inject you with radioactive dye. And
Yep.
that's because they need that because that's how they track what's going through your system. They can scan your whatever organ they're looking at. And they have to inject it immediately as you're going in the machine because it goes out of its decay is so quick. It goes out of your system just that quick. So
I think it's called contrast.
yeah, the contrast, yep.
I used to order it for when I worked in a different department in the hospital.
Very cool. Very cool. So that actually is what we did in 2.6. We learned about exponential equations a little bit more, the parameters A and B. So let's just write down what we learned here. So we have A as our starting value, right? Y-intercept. Make sure we're recording for the folks at home. Yes, we are. And then B is our growth factor. The multiplier. One other thing we can maybe note that would be good for our note sheets to remember is B is going to be bigger than 1 when we have a growth situation. And B is going to be not negative, but between 0 and 1 when it's a decay situation. So we saw that with the coffee, right? So we could say growth is the money example and decay is the coffee example. So